Hi there, and welcome to our next lesson on our C2 topic, chemical resources, and we're going to be looking at acids and bases today. Now just before we start, one of the key terms here is base. Now you may have come across the word alkali before, and an alkali is a type of base. Now an alkali is a base that will dissolve into water, which means all bases are alkalis, but not all alkalis are bases. So an alkali is a base that is dissolved into water. Anyway, let's have a look at our objectives for today. Okay, so let's have a look at our objectives for today's lesson on acids and bases. By the end of this lesson, you should understand what is an acid and what is a base, and also what happens when you react an acid with a base. Okay, now if we understand the pH scale, it's quite easy to give an explanation as to what an acid and a base might be. Now if we look here at the pH scale, we've got the numbers 0 all the way up to 14. Now anything that is 7 in the middle is what we describe as neutral. Now anything in below 7 is therefore an acid, and above 7 is a base. Now, as we said, a base that is dissolved into water is an alkali. Now, often we see the pH scale, and the pH scale is the numbers that we have here, and they relate to the amount of hydrogen that they've got. And pH actually stands for potens, which is Latin for power of hydrogen. Now the colours are when we add universal indicator to a solution. So if we've got a strong acid, it's going to be one of these colours, and if we've got a strong alkali, one of these, and we've got weak alkalis and weak acids here. Now when we add an acid to a base, we have a common reaction. Now this common reaction is where we get an acid plus a base that will make a salt and water. Now the acid and the base are a group of different chemicals, as is the salt. So we're not just referring to table salt that we have at home, and then we have water as well. So if we have a look at an example, we've got here hydrochloric acid, which is obviously the acid, reacting with potassium hydroxide, which is our base, and we're making potassium chloride, which is our salt, and then we've got water. Now here we have a symbol equation, and this is where we have the hydrochloric acid here, which has the formula of HCl. We've got the potassium hydroxide, which is the K for potassium, and then the OH, which is hydroxide. We then have potassium chloride, our salt, which is KCl, and then we've got H2O, which we all know as water. Now that's one example of a neutralisation reaction. Another example, which we've seen recently when we did baking powder in C1, and when we looked at the thermal decomposition of carbonates, we've come across these before. Now when we add an acid to the carbonate, we end up with a salt, we end up with carbon dioxide gas being given off, and again we have the water. Now whenever we have a acid and base reaction, we will have several different parts to the reaction. Now whenever we have a base, there will always be a metal part of it, with the exception of one, which is ammonium, and I'll come on to that in a moment. And the name of the metal will help us to work out what the salt is. So we've got here some common bases which will make different salts. So here we've got sodium hydroxide that will make a sodium salt. Copper oxide will make a copper salt. Calcium carbonate will make a calcium salt, and then we've got ammonia here which will make an ammonium salt. Now, depending on which acid that you react them with will depend on the second part of the salt name. So here we've got some common acids that you will have heard of probably. We've got hydrochloric acid, which will make a chloride salt. Sulfuric acid, which will make a sulfate. Nitric acid will make a nitrate, and phosphoric acid that will make a phosphate. Now, what I'd like you to think about is if we took sodium hydroxide and reacted that with hydrochloric acid, what would we make? Okay, I'd like to pause the video and see if you can write the word and the symbol equation for that reaction. So that's sodium hydroxide with hydrochloric acid. Now, a neutralisation reaction involves ions. Now, ions are charged particles, so they've either gained electrons or they have lost electrons. Now, if we take our first ion, we've got a hydroxide ion. So in one of the equations we looked at earlier, we had potassium hydroxide, and that meant it contained an OH minus ion. Now, if we look at the formula of potassium hydroxide, it's K, and then we've got the OH, and it's the OH which is our ion that we're interested in. Now, in our acid we have hydrogen ions, and this is where we've got the H plus. Okay, so all acids will have an H in it. So for example, HCl, which is hydrochloric acid. Now, this will form what we call a reversible reaction, where the H plus will react with the OH minus, missed our minus off there, to make H2O. And this is where we've got our equilibrium arrow, which should look like that. Unfortunately, my technology won't allow me to do this. Now, one of the key things that you need to remember is if you are asked for a word and symbol equation, you need to make sure that you use the words, if that's what you're asked for, or the symbols, if that's what you're asked for. What I will do is in the questions at the end, I will be putting in a couple of word and symbol equations for you to have a go at. Okay, so we have looked at acids and bases. We've looked at what an alkali is, what a base is. We've looked at salts and how they're made. We've looked at the naming of salts. Remember that the metal from the base will give the metal part of the name, and then depending on the acid we'll get the second part. You know, for example, hydrochloric will give you a chloride. We've also looked at the ions. Remember, an H plus comes from a hydrogen ion, or is a hydrogen ion which comes from the acid, and then we've got the OH minus which comes from the base or alkali that will make water when we have that neutralisation reaction. Anyway, I hope you've enjoyed this, and I'll see you next time. Bye bye.